Hello everyone. Today, we are going to see what is the solver and what are the types of solver that are used in Simulink. So what is solver? Let's see. So this is my MATLAB window. I will open Simulink and then give you a brief overview about types of solvers in Simulink. So let's create a blank model. I'll also take a use case and show you simulation with fixed steps solver as well as variable step solver. So a solver is a computation method used by Simulink to solve any model. If you go in model configuration parameters, you can see different options here. The first option itself is solver. Then we have data import export. We will use this also and I'll tell you how to use it. And here you can see variable step size and fixed step size. There are two options. By default it was variable. So I'll leave it as it is and not change anything for now. Let us come to our use case. So I'll design a system using a switch block. And I'll say the condition for the switch is greater than equal to 0. Once it is greater than equal to 0, I will pass 2 as an input. Otherwise, I'll pass -2 as an input. So I will take two constants. Double click and make it -2. Apply, OK. I will connect this to third input. And I will connect this one to first input. Change it to 2. Now for second input, that is select input. I am going to take array of numbers which will come from Excel. So let this be my input port for now. And at the output, I will put a scope because we have to see the transition from 2 to -2. So this is my basic use case. I'll apply both fixed and variable step and see how the results changes. I'll take my inputs from the Excel. So I'll show you my Excel. I'll delete these two columns. Because anyway, we will get this data when we simulate the model. I am having a time scale t of 0 to 1 second and u is -2 to 2. So as to see state changes in the output. I have to import these in my MATLAB model. So I'll come to MATLAB. I'll say import data. Have to open that Excel which is on desktop. And I'll say open. Now it is in table but I don't want it as a table. I want it as a column vectors. Now as you can see t and u both vectors are there. And I'll say import data. So these variables will now be present in my MATLAB workspace. We can enter the variable name in command window to check the values. Now if I go to configuration parameters, data import, export. I'll use this property. So I will say input. Now currently what I have used in the Excel is u, but if it was some other variable, then I had to rename it here. And I will click connect to input. No need of doing that actually, it will take it by default at the input port. I'll click apply and click OK. This will be my u variable. Let's rename it as u variable. So this is my subsystem. I'll just run it now. I just wanted to show you that it is taking the data points, which I have set. But currently the simulation time is 10 seconds. I'll just change the settings for the solvers. First change the solver settings to variable step. This is already variable step. Instead of auto, I'll select discrete, and instead of 10, as I am having a data of 0.1 to 1. I'll just make the stop time as 1. There is more to solver details, where I will have the step size here. It is auto. Instead of auto, I'll set it as 0.1. And I will click apply and OK. So for variable step, I have done all the configurations which I want. And as you can see here, the simulation time is changed to 1. I'll just move my model up so the scope result can be seen properly. Let's run the model. Now I will check the changes of scope. So my time scale is refined as compared to previous. And here you can see the transition is happening at 0.35. And again, it is changing from -2 to 2. And again from 2 to -2. The falling edge is happening at 0.75. So this is when my variable is variable step size solver. Now coming back to the MATLAB window. If I check the value of T out, I will get these values. I will just copy this value back into Excel so that I can compare it with the data I have given. So I'll just copy one column. As you can see, I have just given a fixed step of 0.1 time input, but here it is taking multiple at 0.35 and 0.75. There are 2 entries for 0.35 and 3 entries for 0.75. So as you can see, the variable step size solver takes more like it is taking 15 steps while I have defined just 11 steps. So this is variable step solver. Now I will go back and I'll change the settings to fixed step solver. So again, I will go to configuration parameters in solver. Instead of variable, I'll make it to fixed step. I will keep this as discrete, same as previous. And again, I will keep this as 0.1. And OK. And now again, I'll run the model. Now, we will check the output on scope, so you can see the output has shifted from 0.35 to 2.4. Now exactly at 0.4 I am getting the transition. And at 0.8 it is coming back to -2. So you can clearly see the difference in the output and the response time. So obviously, the variable step solver detected this change before and it gave me a transition at 0.35. But for fixed step, it is happening at 0.4. I'll also show you the T out for it. So let's go to MATLAB. This will be updated, so I will get a new tout. I'll just copy this back in Excel and this will be exactly identical to my input stream. If you check, exactly 11 samples and with the same duration. So as we can see, the variable steps would adjust the step size, where there is a transition in the input, but for fixed step, there is no change and the same output is observed on the Simulink block. Most of the real-time applications are fixed step solver, and for code generation also, we have to keep a fixed steps or fixed step solver only, because then the simulated or simulation time is known to us. So that's all on fixed step and variable step solver. Thank you for watching.